going to work is that we get the following scenario. And I tried my best to do the uprights. Yes, sir. Either the graph paper's coming around. Yeah, it's getting there. Slowly but surely. All right. So here's what I want to do real quick. Just send them this way. Just send them that way. Yes, that's for you. What I want to do here with you guys real quick is start with the good old-fashioned. I'll get there. I'll show you. What I want to do is kind of start with a table. And we all agree that the absolute value of a number is the distance away it is from 0. Do you agree? Yes. All right. So when I'm graphing these things, I'm going to start with -3, -2, -1, 0, 1, 2, and 3. Those are going to be my values of x. And what I'm going to do here is just real fast with you guys is make just a quick table set of values. This should not be really, really, really scary. Very scary. I'll use my. All right. So. Nicely done. So, what's the absolute value of -3? 3. What is the absolute value? Remember, absolute value of -3. What's the absolute value of -2? And so on. What's the absolute value of 1? 2? 3? It's a lot funnier when we do it like that. Anyway, so now we have our table set of values. So if you recall when you guys first learned how to graph stuff, you always learn how to graph first by making a table. Today is really no different. This is going to show us what this looks like. So all we do is plot. -3 and +3, -2, +2, -1, +1, 0, 0. Uh-oh, we changed direction and we're going that way. It's a V. It's a V. Okay? What is happening here with our absolute value graphs? What's that? No, they're staying positive for right now. So our graphs are going to look like this. All absolute value graphs are in the shape of a V. Some of them will be pointing upward, and some of them will be pointing downward. How do you have an absolute value graph that's negative? Yeah, exactly. You put the opposite. You put the negative value out in front. So here's where you guys are going to be introduced into something that is going to haunt you, fitting for today, for throughout the course of this school year. We use this general form of equations for writing out graphs. And they all tend to look the same. We use what are called A, H's, and K's. All right? And I'm going to explain to you what all these parts mean. For every time that we graph something in this class, from here on out, we're going to graph what's called a parent function. From that parent function, it gets shifted. The shifting means you're going to move it left and right, up and down, and change the amplitude, if you will, or the width of some graphs. When we get into trig function, we're changing the amplitude, we're going to change the period of it, how long it takes for things to cycle, how high up they get, how low they get, things like that. So absolute value graphs all use the same general form. Now, the rules for A, H, and K kind of stay standard across every types of graph that we do. The vertex, where the absolute value graph changes direction, is always at the ordered pair H and K. It opens up if A is positive. So if A is greater than 0, it opens up. If A is less than 0, it opens down. That's how you're able to have those absolute value graphs going up or down. I'll scroll that up some for you. Like I said, the graphs are always V-shaped. Yeah.
You ever have an upside down one starting at origin?
Yeah.
Because it has to be positive.
What is the opposite of the absolute value of x? What's your value of a? Bless you. Exactly. So you wind up with the order of ops, -1 times the absolute value of 2. Absolute value is 2. 2 times -1 is -2. And so on.
No, well, because like, it doesn't say less than or equal to. Oh, okay.
Because if your I know because now you just realized that if your value of a was 0, you'd have a line through a. You'd have a horizontal line. You won't have an absolute value graph. Does that make sense? A is never going to be 0.
Oh, yeah. Okay.
Does that make sense? And then last but not least, and you don't really need to worry so much about being wider or narrower. You're going to find out real quick the a value kind of acts as the slope. No, just slope. So what does this all look like when we start putting it together? We basically take the following scenario. And whenever I graph these A, H's, and K's, I like to kind of formulate a way of doing it that's kind of repetitive. Do you need to be as systematic over the course of time? No. But is it easier to help you guys understand what is actually going on as you're answering these questions? Yes. Especially for the first few of these things, because like I said, this is something new for us. So what we want to do here is I'm going to take this absolute value function, and I have negative absolute value x plus 2 plus 3. And I didn't put it here, but I'm going to kind of make this my step half. What's A, what's H, and what's K? What I want to do is identify those values from the equation prior to doing anything else. Because it takes a second, and it forces me to be able to plot it with ease. What's your value of A? Good. Your value of A is -1. What's your value of H? Good. Everybody see it's -2 because the generic form is x minus h. So if your x value in here is +2, that means it had to have been minus a -2. The generic form is always x minus h.
Oh, so we're doing this, we're going back to like what the original would be?
Mm-hmm. And then your k value is just plain old boring 3. You're going to find that whenever we're using A, H's, and K's, it's generally going to be the opposite of H tacked on a K. So now it's very simple to answer the following questions. The vertex is where? -2 and 3. So I go to -2, 3. Is this one going to open up or down? It's going to open down. So I know it's going to go, it's going to open downward. What's your slope? -1. So from that spot, all I do is just walk slopes and use symmetry. And that's it. And that's your graph.
We just go like to the end of the graph, or is it?
Yeah, that's fine. 3, 4 of them, you're okay, because then you get the idea. And that's it. These absolute value graphs are symmetrical through their origin, through their vertex. You guys remember symmetry? You can fold it on itself. Remember that from parabolas? They're the same thing, they're just not curvy. They're liney. Yes, sir?
Why is A -1?
It was negative because it just had a negative symbol out there. It means it's -1. Because if you don't see something there, it's always assumed to be 1. If you just see a negative symbol, that means they're just being lazy. You just didn't put the -1. That's how us math people roll. Sir. Then it will not be an absolute value. It won't be linear. It'll be something funky. Yes, sir.
What decides if it's up or down?
The value of A. If A is positive, it's up. If A is negative, it's down. Very simple. Yeah. A, and that's why I said A mirrors the actions of slope. And you're going to walk your slope in both directions from that point. And it'll tell you whether to go up or you're down with it. You down with it? Okay. Thanks for not smirking. Don't laugh. You're trying not to. Sure about that? Stone face. What's that?
I've got 2 little brothers at home.
I have 2. And
Our youngest son, we drive over rumble strips, thinks it's hysterical
okay, so go on.
when you're with the speed limit.
Oh,
But when you go over a rumble strip, you just hear him. So you're a year and a half old and you think parts are funny. I mean, it's true. I mean, it's what you do. So let's try another one. Same idea. We have y equals the absolute value of 1/2, or excuse me, 1/2 times the absolute value of x minus 2, and then minus 3.
So do you want us to like always set up this X?
What I'd like you to do is for the first few of these, it's not a bad idea until it starts beating you through your brain enough. Because I'm hoping by the time you get to a couple of the homework problems towards the end of the homework stuff, it'll be like, okay, this is what it is, and you'll go. It's good practice to get into. So I know my A value is 1/2. H here is how much? It's 2. Remember, because it's x minus whatever h is, and h here is just 2. And then k is -3. So that gives me a vertex where? My A value is 1/2, so is it going to be opening up or down? Up. So I go to 2, -3. And once again, mirror your idea of slope. My slope is up 1, right 2. And go in the other direction, use your symmetry. Up 1, left 2. And so on. So now you have another one. Really isn't that as bad as it sounded. See, you have? Why do you guys did absolute value?
I don't remember.
It took us like a week to cover like the section.
Oh, I didn't realize you guys had. I didn't know that you guys had done that. That's cool. But were you guys introduced to this though? The AHEK?
No.
Okay, you just did what? Good old fashioned plug and chug?
Yeah, dude, my teacher last
Okay.
year.
He was in his shirt, wasn't he?
Yeah, dude.
Yeah, he had no idea what he was talking about. All right. Try this one. Try this one. If you guys have done absolute value, maybe I won't have. Are we okay with h being 0 here? K is +3.
If h wasn't 0, it would be a negative, right?
If h wasn't 0,
This equation.
no. Because if example, if you had, if it was x plus 2, what's your h?
2,
Negative 2. If it's x minus 2, what's your h? 2. The h value is generally, when you're looking at it in the problem, it's the opposite of what you see. The k value is the same. All right. Here there's just no h, so it's 0. That means my origin is at 0, 3, and my slope is oops. Should we shade these?
Yeah.
We don't shade these. No, because that's nasty. Because you'd have to shade within the parameter. I mean, there's no es bueno. What we shall say. You know what? We'll go to the right in the equation then on Monday. We'll call it here.
Yay.
So I know you won't do your homework anyway. It was what? Page 126? That's what you said. 18 through 25. All right?